the path between 2 points. Okay, and work done is said to be zero when the path is perpendicular to the electric field, and also work done is said to be zero in a closed contour. That means the starting point and ending points are same. This is what we have discussed yesterday, and we have also discussed about the concept of absolute potential. That means we have measured the potentials of different points with respect to some common position. That common position is nothing but reference position, and it is assumed that zero potential. The zero reference point is selected as a ground here. So that potential of the point with respect to that reference is nothing but the absolute potential of that point. Okay, so this is what we have discussed, and also we have discussed the potential due to different charge distributions. So that is a point charge distribution, line charge distribution, and volume charge distribution. Like that we have discussed. Let us recall those relationships. So, so potential due to a point charge. So that is nothing but potential due to point charge at a given point. So it is nothing but VAB. VAB is equal to Q by 4 pi epsilon naught 1 by RA minus 1 by RB. So this is what we have discussed today. It means potential difference between 2 points. So A and B, where the charge is moved from B to A. B to A, that means potential difference is VAB, that is VA minus VB. Okay, and the charge is at the origin. The charge is at the origin. Okay, so this is when charge is at the origin, and VAB when charge is not at the origin. So you can call it as VA, that is a potential, is Q by 4 pi epsilon naught, uh, magnitude of R minus R dash. So R dash is the distance of the charge from the origin. R is the distance of the point from the origin, and R minus R dash is the distance, is not the distance vector, it is only the position of the point A. Okay, this is what point charge. One second. Yes, now line charge we have discussed. Potential due to line charge. If you could remember, VA is equal to V of R, that is equal to line integral rho L of R dash dl by 4 pi epsilon naught, it is R minus R dash. Okay, so rho L is not constant here, it is varying with respect to the distance, varying with respect to the distance. Okay, next surface charge we have discussed again. VA is equal to V of R is surface integral rho s of r dash ds 4 pi epsilon naught r minus r dash. It is nothing but the magnitude. Okay, this surface charge. Next, volume charge. Potential due to volume charge. VA is nothing but V of R. Okay, it is a volume integral rho V R dash by 4 pi epsilon naught R minus R dash. All these things we have discussed yesterday. Okay. Yes. Now we shall solve some problems here so that you will understand the concepts better. Okay. So if it is clear up till now, we can type 0 on the chat box quickly. Yes. Let us solve the problem. First problem. Take down the problem. An electrostatic field is given by E vector minus 8 into xy ax cap minus 4x square ay cap plus az cap volts per meter. The electrostatic field is given by E vector, that is equal to minus 8xy into ax cap minus 4x squared into ay plus az volts per meter. Okay, continue. The charge of 6 coulomb, the charge of 6 coulomb is to be moved, is to be moved from B coordinates 1, 8, 5 to A coordinates 2, 18, 6. Okay. So charge of 6 coulomb is to be moved from B1, 8, 5 to A 2, 8, 6. Find the work done. Find the work done. So you're supposed to find the work done. Okay. When the path is y is equal to 3 square x plus z, and z is equal to x plus 4. Okay. Next, another path is given, straight line from B to A. So you are supposed to find work done when path is this one, described by these equations, and also you are supposed to find work done when the path is a straight line from B to A. So electric field intensity is given, charge value is given, and the coordinates of B to A is given, and you are supposed to find the work done in the path. The first path is y is equal to 3x square plus z, and z is equal to x plus 4, and we have to find again work done when the path is a straight line from B to A. So let us solve this problem. Okay. This is the problem. Yes. Okay. So let us write the equation first. Equation for work done. This is the problem. So work done equation we know W is equal to minus Q times into B to A E vector into DL vector. Okay. So E vector is given. We're supposed to find DL vector, that the Cartesian coordinate system you can find, that is dx into ax cap dy into ay cap plus dz into az cap. Okay, and e dot e vector dot dl vector, that is dot product of electric field intensity and the distance vector. Okay, if you do it, multiply the electric field intensity and the dl vector, so you'll be getting minus 8 into xy into dx minus 4x square into dy plus dz. Okay, so ax cap into ay cap will be 0, ax cap into az cap will be 0. So we'll be getting only the terms corresponding to the similar unit vectors. Okay, yes. Now if you substitute the values in the integral, so w is equal to minus of q into b to a. Okay, b to a. So it is minus 8xy into dx minus 4x square into dy plus dz. Okay. Now split this integral minus minus of q. Okay. Integral of b to a minus 8xy dx minus b to a 4x square dy plus b to a dz. This is what the simplified expression. Okay, let us take this one on to the next slide. Okay, now let me simplify. So we have got expressions now. So limits also we know, x limits, y limits, and z limits we also know from the coordinates. Okay, and we have got the expression for y is equal to 3x square plus z. So we know that y is equal to 3x square plus z, but z is given, it is x plus 4. Okay, so x plus 4. So now you can substitute in the above expressions wherever required. Okay, then you can simplify, and this is why, and differentiate this one. Dy is equal to, okay, it is nothing but 6x plus 1, okay, and z is given, that is x plus 4. Dz is equal to dx, that we have to know. Okay, yes, just substitute here in the above expression q into integral of e to a minus 8 into x into, replace y by the expression x 3x square plus x plus 4 into dx plus b to a 4x square, okay, dy. Dy we know is
Minus, sir.
6x plus 1, yes, minus, correct,
Minus integral b to a for x.
minus, okay, next plus integral b to a dz we know, you can keep it as dz itself or you can keep it as dx if you wish to. So I'll keep it as dz itself. Okay. Now you can substitute the limits and apply integration with respect to x. You can get the um, solution. Okay. Yes. Let me substitute the limits. The q value is given to you. That is 6. Limits is also given to you. So I have got integration with respect to dx. So I have to substitute the x limits. X limits is from b to a, that is 1 to 2. It is minus 24x cube minus 8x square minus 32 dx. And again, x limits you have to take. So it is 1 to 2. It is 24x cube plus 4x square dx. And z limits I have to take. Z limits is 5 to 6 dz. So if you substitute, or if you're on application of integration, you'll be substituting the values of the limits also. You'll be solving as 1530 joules. This is the work done. So I'm not integrating it. Okay, I'm just leaving to you. So I'll be getting as 1530 joules. Yes, it is mathematical, again, jugglery, we can say. The concept you have to apply is work done, how to solve for work done when field is given. So you need 1530 joules of energy to move the charge of 6 coulomb from B to A when an electric field is uh, minus 8xy in x direction, minus 4x squared in y direction, and 1 units in the z direction. Okay, so this is what the work done in joules. The first part of the problem is over. The path is chosen as like this. This is the first part. So I have used the equations for y and z, and using this path, the energy expended is 1530 joules. Now I have to find the work done in when the path is straight line from B to A. Straight line from B to A. Let us see that one. Yes. So it is case 2. It is straight line from B to A. The energy expended or work done should remain same here because the work done is independent of the path selected. Okay, so now we have got the B coordinates 185 to A coordinates 218.6. So I have to use the coordinates of A and B so that I can solve for the expressions. So it is again fundamentals of linear equations. So y minus yb is equal to ya minus yb by xa minus xb, and similarly z minus zb is equal to za minus zb by uh, this is x minus xb. Sorry, za minus zb by ya minus yb multiplied by y minus yb. Similarly, x minus xb is equal to xa minus xb divided by za minus zb, okay, multiplied by z minus zb. Using these equations, you can form any two equations and then substitute in the work done equation, you will get the answer. Okay, so same equations you have to use. W is equal to minus q into this b to a e vector into dl vector. Okay, yes, if you just use it, that is equation minus q into integral of b to a. So we got the product 8xy dx minus 4x squared dy plus dz. Okay, and you can solve for any two coordinates equation. So y is equal to 10x minus 2 and 10z is equal to y plus 42. Okay, these two equations you can solve, substitute here, and you'll get the answer. The answer would be, and apply the limits also, the answer will be 1530 joules. Okay, so you can use any two of these three equations to get the coordinate equations, linear coordinate equations in terms of x or in terms of y or in terms of z. Okay, and then you can simplify the integral expression, and if you substitute the limits, you'll get the same answer. You should get the same answer. Okay, yes. So if you got any doubts, you can ask me. Else, you can type 0 in the chat box. We shall move on. If you want some time to write down, I'll just wait for a few minutes. Yes, we should solve one more problem. So we have got axis like this. Okay, this is y, z, and x. Let me have infinite line charge like this along z axis, along z axis, and I have to move a charge from this point in a circular fashion like this. Mhm. So the radius of this is given to be r, okay, and it is at the center. So I have to move a point charge in circular fashion. So on z is equal to zero plane, z is equal to zero plane, that is xy plane. So I just have to move a charge like this on a circular fashion with the radius r. So with the radius r. So what exactly the work done? I have to find it. Can somebody tell me?
Zero.
Yes, it is zero. Zero is the right answer. How?
Because the smallest distance is zero, no sir. Starting point and ending point are same.
Yeah, that is one way. And the other way is the path. Just check out the path. Path is on the xy plane and the field is on the z plane, sorry, z axis. The field is on the z axis and path is on the xy plane. So the path is perpendicular to the field. The path is perpendicular to the field. There is a line charge, and for example, if you take the field directions like this is the field direction. So this is the field direction, and you can expect the field like this. Okay, so if you just try to move along this directions, okay, that means like this. If you are moving in a closed path in a circular fashion, what happens? The path is perpendicular to what the field direction. As a result, the work done will be zero. We can also prove it. Just check out here the distance dl. Okay, in terms of the cylindrical coordinates, you can write that is r into d phi into a phi cap. So this is in terms of cylindrical coordinates, and E vector is equal to electric field due to infinite line charge. Can somebody recall the formula? Electric field
Royal by epsilon naught.
rho L by 2 pi epsilon naught, and the distance uh, at this point is r. Okay, so it is r, and the field direction will be along the radial one. It is a r cap. So if you just multiply e vector and dl vector, so what happens here? R into d phi into a phi cap multiplied by that is rho L by 2 pi epsilon naught r into ar cap. So a phi cap into ar cap, both are what the perpendicular quantities and normal to each other. Therefore, the dot product of two unit vectors which are normal to each other, it is zero. Therefore, the product is zero. Therefore, the work done minus q times into E vector dot dl vector is equal to what? 0. Got it? Is it clear? So if this concept is clear, please type 0 on the chat box. Next, we should solve one more problem. Determine determine the work done in carrying work done in carrying a charge of 2 coulomb charge of 2 coulomb from B 101 to A 0.8.61 in an electric field y into ax cap plus x into ay cap 2z 2 into az cap volts per meter along the short arc of circle x square plus y square is equal to 1 and z is equal to 1. So this is the path. This is the path of the movement from B to A. Okay. Somehow you find the product E dot, this dot product of E vector and dl vector first, and then simplify and get me the answer quickly. And the limits are also given to you. Just substitute the values and get me the answer. Yes, I'll just keep this for a few minutes. I want somebody to solve this one, please. What is dot product of E vector and DL vector? Hello? E vector dot DL vector.
y dx plus x dy plus 2 dz.
X dy plus 2 dz. Yes, correct. Now you can write y in terms of x and x in terms of y using the relationship, and you can keep z is equal to 1 as it is, and substitute these things in the expression and get me the answer.
Minus 0.96.
Minus 0.96 joules. And what do you understand by this minus 0.96 joules? Yes, what do you understand by this? Hello? Work done is work done is negative.
Electric field.
Work done is done by the electric field. Correct? Yes or no? Hello? Vaibhav?
Yes, sir.
Vaibhav?
Yes, sir.
Yeah, following. Hello? Hello?
Yes, sir.
Yeah, work done is negative means what do you interpret?
So the work is being done in the direction of electric field, sir.
Yes, the work itself is done by the electric field. Okay, that means no external force is required. The electric field itself has done the work in moving the charge from B to A. Okay, yes. So this is what the answer, that is minus 0.96 joules. Okay, yes. Next, we shall solve one more problem. Find the work done. Find the work done in moving in moving in moving 4 microcoulomb charge from origin to minus 1 minus 4. Okay, origin to 2 minus 1 minus 4, and the field is given 2x yz ax cap and x square z ay cap x squared y az cap. Okay, the paths are given. Z is equal to 2x and x is equal to minus 2y. Line segments, straight line segments. And the second path is also given. Curve x is equal to minus 2y cube and z is equal to 4y square. So you have to find work done in both the paths, one along the straight line segments and one along the curve. X is equal to minus 2y cube and z is equal to 4y square. Yes. So just I'll leave this slide for a few minutes. Please try to solve and get me the answer for the work done. Put in your honest attempt. If you don't solve here, you will not be solving in the exam. So try to put honest efforts. Finished? What is that you can do? You can convert any coordinate system to any other coordinate systems, and then you can use it, or you can use always the Cartesian coordinate systems if it is given on the cylindrical or spherical coordinate systems. Now it is Cartesian coordinate system only. Okay. Yes. What is the answer you got? Hello. Okay. So I'll write the answer. So work done will be around 64 microjoules. 64 microjoules. Sangma, are you able to solve?
Yes, sir. I'm trying.
Okay. Jayesh Shah. Hello. Jayesh. Chandana. Gokul.
Yes, sir.
Are you
Did.
able to follow?
Yes, sir. I'm able to follow, sir.
Yeah. Uwais.
Yes, sir.
Shivraj. Shivraj.
Yes, sir.
Are you able to follow?
Yes, sir. Yes, sir.
Yes. Vidya. Vidya.
Yes, sir.
Are you able to solve the problem?
Yes, sir.
Okay. Zishan.
Yes, sir.
No doubts up till now.
No, sir. Solving, sir.
Solved. Got this 64 microjoules answer?
Sir, solving, sir.
Okay. Yes. We shall move on for the next variant of the problem. Take down a point charge. A point charge Q is equal to zero point 0.4 nanocoulomb is at origin origin. Obtain absolute potential at A 2 comma 2 comma 3. Absolute potential at A. Very simple. So I am to solve for VA. It is nothing but Q by 4 pi epsilon naught that is RA, that is R minus R dash magnitude. So R minus R dash magnitude square root of 2 minus 0 square, 2 minus 0 square, 3 minus 0 square, that is equal to root 17. And if you substitute the value in VA, that turns out to about 0.8719 volts. So this is the absolute potential of point A with respect to the reference. Okay, got it? Next. So you just take down this one. Yes. Next, we shall move on. So find the potential difference VAB when the charge is moved, charge of 4, that is 0.4 nanocoulomb, 0.4 nanocoulomb is moved from B to A, from B to A, B to A. A is 2 to 3 and B is minus 2, 3, 3. Potential difference from B to A. Okay. So how to solve this problem? We have already solved for VA now. Okay. So the VA value, there is absolute potential of um, you have to solve for VA. There is absolute potential at point A and absolute potential at point B. So VA minus VB is equal to VAB. This is the answer. First, you have to solve for VAB. Next, you have to solve for VB. That is, so first you solve for VA and then you have to solve for VB. Then you can solve for VAB. Okay. Yes. I'll just leave this slide for a few minutes. Please solve for absolute potential VA and VB and VAB. Okay, there is a small change here. Here still the charge is at origin only. Charge is at origin only. Okay, so I will just write the coordinates. So you are having charge at this point. For example, I'm having A and B here. Okay, so I have to find VA and VB and VB. So potential at A due to charge at origin, potential at B due to charge at origin with respect to the reference. Okay, and similarly you can solve for VA minus VB. That becomes VAB. So you have solved for VA that we already know. So it is 0.8719 from the previous problem. And you have to solve for VB. Solve for VB. Okay.
So 0.7669.
Point
7669.
7669.
Yes, sir.
Correct. Next, VA minus VB, that is equal to
0.1049.
0.1049.
49.
So you have assumed that the charge is at origin itself, right? Correct?
Sir. Yes, sir. Yes, sir.
Yes. Then it's okay. So all are volts. Yes. Next problem. Last problem today. So there are three charges. If there are three charges, 3 microcoulomb, 4 microcoulomb, and 5 microcoulomb are located at 0, 0, 0, 2, minus 1, 3, 0, 4, minus 2. Find potential at some point P, that is 1, 0, 1. Okay. So these are the 3 points. So you are supposed to find the potential at point P due to the charges located at A, B, and C. Okay. So this is what the problem. So we have got the expression. That means you can solve the potential at P due to A charge. You can solve potential at P due to P charge. You can solve potential at P due to C charge. Okay. So these things you can find out. Okay. Then you can just add all those things. You'll get the final answer. The formula I'll write here. QA divided by 4 pi epsilon naught RAP or RPA. QB divided by 4 pi epsilon naught RAP or BP, that is BP or PB. QC divided by 4 pi epsilon naught RCP or RPC. This is a standard expression. We are supposed to find RAP, RBP, and RCP. That we shall solve. RAP is square root of, okay, that is square root of 1 minus 0 square plus 0 minus 0 square 1 minus 0 square, because A is located at origin and P is at 1 0 1. Okay, next RBP. P is at now 2 minus 1 3. P is at 1 0 1. So square root of 1 minus 2 square, 0 minus of minus 1 square, 1 minus 3 square. Next RCP. C is at which point now? 0 4 minus 2, 1 0 1. P and P here. Square root of 1 minus 0 square, 0 minus 4 square, 1 minus of minus 2 square. If you just simplify these things and substitute back in the potentials at A, B, C, you'll be able to solve for the total potential at P due to 3 charges. Okay, solve for the values and get me the answer.
Sir, VA is equal to 19.076 kilovolt.
Correct.
VB is equal to 14.685 kilovolt. VC is equal to
minus 14.67.
sir, but Q is given as 4 microcoulombs.
Okay, okay. Q is given as 4. Yes,
Yes,
4
sir.
microcoulomb. Then it is right. Next.
14, VC is equal to 8.818 kilovolt.
Correct, correct. No.
Total 42.579 kilovolt.
Okay. 8.8 plus 14.6 plus 19.06. 33 plus 8 is 42, right?
Yes, sir.
Okay. Okay. So what I will do, I'll just stop at this point. So we should continue with problems on line charge, surface charge, and volume charge in the next session. Okay. If you have got any doubts, you can ask me. Else, you can exit for the next class. I'll just let you know the details of the next class. So I'll be taking next class by means on tomorrow or the day after tomorrow during some time. I'll just let you know the timings. Yes, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes, sir.